Good evening. Welcome to everyone, all our guests here, faculty, staff, students, alumni. It's so nice to have so many people here this evening for this talk. My name's Joanne Brown. I'm an assistant professor in the Department of Physics and Astronomy here at the University of Calgary, and for tonight, I get to be your MC. Thank you for joining us. In a moment, we'll be welcoming Dr. Anthea Coster here. This is the first time that she'll be giving a talk of this magnitude on this topic, but she's very well known to many people here at the university. She works with people both in engineering and in science here. But before we get to that, I'd like to first introduce Dr. Leslie Reed from the Faculty of Science, who's the Associate Dean of Teaching and Learning here in the Faculty of Science. She leads projects and initiatives to support and enhance teaching and learning in the Faculty of Science. Both her and Dr. Chao Sun from engineering are very keen supporters and champions for women in science and engineering, and we're supportive of my quest to bring Dr. Coster here this evening. I'm now pleased to introduce Dr. Leslie Reed.
Thank you, Joanne. It is my pleasure to welcome all of you to the University of Calgary. On behalf of the Faculties of Arts, the Faculties of Science, and the Schulich School of Engineering, we are so pleased to have you join us this evening. When Joanne approached myself and my colleague Susan Scone, who is the Associate Dean of Research in the Schulich School of Engineering, she approached us about 6 months ago with the Anthea Coster story of Lise Meitner, and what an amazing journey and an amazing story this was. And Susan and I were thrilled to be able to work with Joanne to make this event happen here tonight. It is really satisfying to see over 400 people here this evening to hear the amazing story of resiliency, family, history, and science that Dr. Coster will weave for us today. Dr. Coster, thank you for coming to Calgary to share with us this powerful story of Lise Meitner, a pioneer in nuclear physics and co-discoverer of nuclear fission. Her career, achievements, and determination serve as tremendous examples for all of us here today, and I am really looking forward to learning more.
Thank you, Leslie, for helping set the stage for tonight's event. Shortly, we will welcome Dr. Coster to share her personal stories and professional connection with Lise Meitner. After that, we'll have some opportunity for question and answer period following her talk, and then after that, we'll have a dessert reception on the second and third floor. Right? So for those of you that are up higher, you're closer to the food. And I should also make a note, if you'd like to take the elevators up the second and third floor, take the east elevators, so behind you, not the ones over here, because you need a special key to get up these elevators, so just go that way. All right. Another point to note, Dr. Coster's lecture will be videotaped, but the question and answer period will not be, so don't be afraid to ask questions. There will be no videotape on you. Okay, let me take a moment to let you know a little bit more about Dr. Coster. I was first actually introduced to Anthea just over a year ago by my husband Eric Donovan, who is also a space physicist here at the University of Calgary. And I was looking for somebody to do a public lecture at a conference I was organizing in Seattle. And he suggested her, so I contacted her, and she agreed, which I was very excited about. And then once I saw her talk in Seattle, I decided I really, really, really wanted to have her come and give a talk to more than just a small physics group that she typically gives a talk to. And so here we are tonight. Now, Doctor, I'm not done. So Dr. Coster received her PhD in space physics and astronomy from Rice University in Houston, Texas in 1983. She is now the principal research scientist in atmospheric science group at MIT Haystack Observatory, where she leads a number of studies focused on studying the ionosphere. And it turns out Anthea didn't know much about her connection to Lise Meitner until the 1970s, when the author, Ruth Lewin Sims, started writing her dad, asking some very unusual questions about her grandfather. And with that introduction, I'd like us to welcome our special guest, Dr. Anthea Coster.
So can everybody hear me, I hope? I'm really kind of amazed. As I said, I was given all of this material. It's unlike normal physics talks where I've worked and tried to come up with research. This material was handed to me primarily because of who I am. And when I say who I am, I should make it very clear to people. I grew up in Houston, Texas. It's a little bit like Calgary. And especially when I was growing up. Now it's a little bit bigger. But I had really very little connection with the Dutch side of my family. My grandparents both passed away before I was born. And I really didn't know much about really anything about the war years or any of this personal history. And actually, I was talking to a friend of mine tonight. We both knew each other in the 1970s. And she said, well, I didn't know this. And so I can't really tell you exactly when I became aware of all of these stories. But I can tell you, I went back to Holland about 4 years ago, and I realized I have one aunt that actually had just had a stroke, and she's since passed away, another aunt who has Alzheimer's, and an uncle who actually has had open heart surgery. My father passed away 20 years ago. That meant that all of the stories they were telling me were going to essentially fade away. And then when I looked among all my cousins, I'm the only one in physics, so I'm the only one who really knew people who might appreciate, well, that I thought, I don't know how many of you were in physics, but I thought I was the only one who had the kind of responsibility to kind of put everything I was given and make it into a story. And I do think I focused it on Lise Meitner because I think, especially nowadays, there are many elements in this story that you should listen to. And it's not just because of who she was and that she was a woman scientist, but it's also everything about what she went through and everything that was going on in Germany during World War II. We need to kind of take heed and look at our own reactions, not only as a citizen, but as a scientist and as an individual. All of this, our role in society is important, and I think there are many themes in here that I hope that you can grab onto. So if nothing else, I hope everybody here by the end of this talk knows who Lise Meitner is. This is a picture of her. I'm gonna give you an introduction which actually talks more about my family history. I'll describe her early years and then her escape from Germany, the discovery of fission, and later years, and some interesting comments actually that came from my aunts and uncles. Now, as I said, I first became aware when the author of this book, which was written, she's a professor at the Ruth Lewin Sim. It's called Lise Meitner, A Life in Physics. She started writing this in the late 1960s. I do think it took her 30 years to get it published. She started writing it because she was a chemistry teacher in Sacramento, and there was no mention of Lise Meitner in her chemistry textbook. And you know, here she is, a really important woman scientist, and she was just totally overlooked. So she actually took it on herself to start documenting all of her accomplishments and everything she went through. I highly recommend this book, and I've definitely I've been in contact with the author several times. She knows I'm giving this talk, but this is going to have more of thorough background than anything. I have had to cut it down, obviously, for the talk. The other person who I think you're going to be seeing excerpts from a film, I think it's called The Path to Nuclear Fission, a story of Lise Meitner and Otto Hahn. That was shown on PBS, and we're trying to remember how long ago. It was about 10 years ago. The film was done by Rosemary Reed. She gave me a copy of her film just because of who I am. And she knows that I've excerpted part of it to show here tonight. And I've done that because the film shows you some things that I really can't capture, and you'll see why later. So to begin, the first thing I found this quote, and I thought it very much applied to everything I'm going to be talking about. And that is, when female stories are muted, we are teaching our kids that their dignity is second class, and the historical accounts of their lives are less relevant. Now, this quote was actually written by someone who had just discovered that Martin Luther King's mother was assassinated. That's a fact I wasn't unaware about. But I think this is also true for Lise Meitner. Why was her story muted when she played such a central role in nuclear physics in the middle of this century? So again, who was Lise Meitner? Well, she discovered the element protactinium, which is number 91, with Otto Hahn in 1918. But I want you to know that she was the one, Otto Hahn was actually fighting on the German front in World War I at this time. She puts his name as first author on the paper, but most of the work and the writing of the paper was done by Lise Meitner. She discovers what's called the Auger effect in 1922, except it actually gets named after a French scientist, Auger, who discovers it in 1923. Now, one reason it didn't get noticed as much when she discovered it is that when she wrote the paper, it's kind of buried in the middle, and it's not, it was a 17-page paper, and her description of it doesn't perhaps emphasize it as much as Auger did the following year. She is the first person to interpret fission, and she names fission. Okay, so she's the one who interpreted what the chemical results were. She is nominated for the Nobel Prize 12 times. She does not get it. And the element meitnerium 109 is named after her, and that actually happened recently. And I would say it's probably in large part due to this book, because people are realizing she wasn't getting the recognition that she probably should have been. Now, here is a picture I found out recently. It was taken in 1935, where it shows, this is Max von Laue. He's a Nobel Prize winner. This was taken in Germany at what is now a Max Planck Institute. It was the one for chemistry. And she was actually, at this time, she was head of the physics department in the Max Planck Institute for Chemistry. And this is my grandfather right here, Dirk Coster. Now, when I first saw this photograph, was very pleased to see it because he's standing up. Now, my grandfather had MS, and so most of the photographs in his later life, and he dies actually in 1950, he's sitting down in a chair. He can no longer stand. So I was very pleased to see this photograph in my aunt's album. And this is a photograph, and I find it very, very interesting, that wasn't developed until the author started writing my father. And the author was actually looking for a photograph of my grandparents that she could use in the book. And it's funny, he didn't send her this photograph. He sent her another one that was taken at the same time, which is just of my grandparents. This is my aunt, this is my uncle, this is my father, and this is my other aunt. But you'll notice there's two other people here in this photograph. There is the girl Judith and Mevrouw Cohen. And the reason this is unusual is, yes, they were actually hiding Jewish people in their house. Now, you should know, at this time, it's March 1945. They're in Groningen. My grandfather was a professor of physics at the University of Groningen. At this time, both my father and my aunt are also in hiding. They're supposed to be working in Germany. But the thing that I always find kind of odd is that, I didn't learn about this until I was at least 18 or 19, and this is despite the fact that my parents made a big deal that I read The Diary of Anne Frank, that I saw the play The Diary of Anne Frank, but it was never mentioned that at any time there were Jewish people living in the house. And I think when I look back at it, and I know people here may not think of it this way, but Houston is actually a very, very international city. And I was actually going to school with people whose fathers actually were in Patton's army. Also, I was going to school with children of Holocaust survivors. So I think my father felt very uncomfortable of talking about anything to do with the war years, and so it was never mentioned in my house. And finally, this is a painting that my aunts actually commissioned. If you ever go to the University of Groningen, it's in some big, elaborate hall. His claim to fame, just so if we get it out, he actually was a co-discoverer of the element hafnium, and it was important because it actually was predicted by Niels Bohr, and he was actually working in Niels Bohr's laboratory at the time. And it confirmed that Niels Bohr's theory, his theory of how the atomic table is laid out. When they found it, it confirmed that Bohr had the right organization of the atomic elements. And so it actually is mentioned at the very end of Niels Bohr's Nobel Prize winning lecture. He mentions the discovery of this element, hafnium, which actually hafnium means Copenhagen in Latin. So, early years with some diversions. Lise Meitner was born in November 7th, 1878. She's the third of 8 children, and she's born in Vienna, the capital of the Austro-Hungarian Empire. Now, her father was a lawyer, and he was one of the first Jewish men who were free to study law and be admitted into its practice, and her mother was a musician. And it turns out that in the middle of the 18th century, Vienna was a very progressive city. There were a lot of changes, a lot was happening, and her family, which was of middle Jewish class descent, but really they surrounded themselves with liberal, intellectual, professional friends of the family, more than religion in the synagogue. They were really into the intellectual life. And he was very, very encouraging of her and her intellectual pursuits. Now, at that time in Vienna, girls are only educated until age 14. We kind of forget about all this, but due to her family environment, and in fact, due to primarily her father, all Meitner children received an advanced education. And finally, in 1897, Austrian universities became open to women, okay? But to get into it, they have to pass what's called a matura, or an entrance examination. And so she actually crams pretty much 8 years of courses into 2 years, and she passes it in July 1901 at the age of 23, and she's one of 4 girls out of 14 that passes. Now, one of the other students is Henriette Boltzmann, the daughter of Ludwig Boltzmann, who you're going to hear about. I mean, anybody in physics knows who Boltzmann is. His daughter is one of the other ones that passes. And she enters the University of Vienna in October 1901. She is actually the very first woman to be admitted to the physics department. And her first professor, and actually her PhD advisor, is someone named Franz Exner. But in her second year, she takes a lot of physics courses by the famous theoretical professor Ludwig Boltzmann. And he basically accepts women as a matter of course. I think I've learned that the woman he married actually was already attending lectures at the University of Vienna before they let her in. And he believes, by the way, that the atom is divisible, even though that went against scientists who said that God had not intended it to be so. So he's a very famous scientist, and he presents beautiful and stimulating lectures. And so she attends them and takes copious notes. Now, she is actually the second woman to earn a doctoral degree in physics in 1906 at the University of Vienna. And her PhD is called A Test of a Formula of Maxwell's. Her PhD advisor commends her for a not entirely easy investigation that was brought to completion not without experimental skill. So you can see this is really building her confidence. After she gets her PhD, the only work she can find is as an unpaid assistant to an assistant in the university's laboratory. So after she completes her PhD, she studies these Boltzmann lecture notes, along with others' work, including Lord Rayleigh, with Paul Ehrenfest. And he's going to play an important role. He's going to play an important role in this talk later on. And he's a theoretical physicist at her age who's taken his PhD with Boltzmann a few years ago. Now, this actually is, and you'll see why we're taking a little diversion here. This is Boltzmann. This is actually in 1919, and it's in Holland. And remember I said my grandfather, who's Dutch, Paul Ehrenfest is his advisor, and he takes him under the wing. He ends up taking the position of physics over from Hendrik Lorentz. And this here is in Holland. You have Ehrenfest, Lorentz. This is Niels Bohr. And this is, and I'm going to mispronounce this along with many other things in the talk, Heike Kamerlingh-Onnes. He's actually the person who wins a Nobel Prize for superconductivity. But these three guys are Dutch. This is in Holland at the University of Leiden, which is where my grandfather attends. And it shows you that in 1919, Holland was a hotbed of physics. And this actually is a photograph that came from my aunt's album. Again, it shows you Paul Ehrenfest. And the next, I'm going to show you the next one of my grandfather, and I'm going to try and show you what kind of man he was. He was a wonderful man. This here is a photograph of my grandfather, and you can see he doesn't look very happy. And the reason is my grandfather came from a family of 11 people from the slums of Amsterdam. And at that time, the highest education you could get was as a instructor, a teaching instructor. So he went through teachers training college, and he had to work off 2 or 3 years to pay off his training for the teachers program. But luckily, somebody in Holland recognized how smart he was and said, if you can pass, again, the university entrance exams, which at that time includes Greek and Latin, if you can pass them, we will find you a way to attend the University of Leiden on scholarship. And so he actually does get to Leiden. He becomes adopted by Paul Ehrenfest, and that's even kind of a funny relationship because my grandfather was an experimental physicist. Ehrenfest is more a theoretical physicist. But I have even read somewhere that he was one of Ehrenfest's most favorite students. He was very hardworking, I'll say, about my grandfather. But Ehrenfest, who, remember, he has taken the position of Lorentz. He's a famous, famous physics professor. He demands to go meet my grandparents, or great-grandparents it is, in the slums of Amsterdam. So it just shows you he was a really, really kind and generous person. So back to Lise Meitner. So, okay, she's able, one of the things that gave her a lot of confidence is that she's able to answer a problem that's unanswered by Lord Rayleigh, and she writes the report, Some Conclusions Derived from the Fresnel Reflection Formula. And this report gives her enough confidence to let her know that she can do independent scientific work. So at that time, Boltzmann, who again is a very, very famous physicist, he takes his life. He's 52 years old. And one of the reasons he may have given such stimulating and amazing lectures is he also suffered from manic depression. So that in one of his depressive phases, he ends up taking his life. I also show here that Paul Ehrenfest actually did the same thing when he was 52 years of age. Now, he did it in 1933, which, if you know, he is Jewish, is at the time when Hitler comes to power in Germany. That may or may not have played into it because he also clearly suffered from depression and was worried that he was kind of losing some of his faculties. But nevertheless, it wasn't a very traumatic time period. But going back to Lise Meitner, she actually asks her parents and receives permission to go to Berlin to study at the University of Berlin under Max Planck, because he's one of the other leading physicists at that time. And so when she gets to Berlin, and I should let you know, at that time, women were still not allowed into the University of Berlin. Max Planck really doesn't understand why she's there because she's already got her degree. So she's not allowed to matriculate at the university. However, they do arrange for her to have a lab in the basement, and I think it's in the chemistry building, where she's literally not permitted to climb the stairs to the higher levels where the male scientists work. And in fact, she has to go down the street to go use the restroom. I mean, they won't even let her have any access to the facilities in the building. But nevertheless, in the lab in the basement of the chemistry building, there is a carpentry room with 3 microscopes, and she can begin to use this facility to count alpha, beta, and gamma rays. And this is part of the studies of radiation that were beginning to actually help people determine how the atom is actually, what's made of. Now, she depends on her family for a monthly allowance until 1912, when she's finally given a position grading papers for Max Planck. Now, 1912, she's 32 years old. However, at that first, right in 1907, she meets with and becomes a collaborator with Otto Hahn. He's a chemist, and she's a physicist, but together, he's interested also in radioactivity, and together they made a tremendous team. They basically start a 30-year scientific partnership together, and they systematically measured the beta radiation of every radioactive element and studied their spectra. They explained radioactive recoil. They discovered the element protactinium. She explains the Auger effect, which is radiationless transition of electrons. So they have a very, very fruitful collaboration, and it's partly because this is a new field, and they need this collaboration between physicists and chemists. And I should say that their relationship is always professional. In fact, maybe partly because they were working so closely together. In Germany, there's a formal and an informal use of how you address each other. They used and maintained that formal discussion with each other for, I think, all of their lives, or certainly for the next 25 years. In 1919, in all likelihood, she was the first woman in Germany to be given the title of professor at the Kaiser Wilhelm Institute. It's the one for chemistry. And again, these became, after the war, the Max Planck Institute. And it is one thing that is important to note here, they are a private institute. They're not part of the state. So they are a private institute for science. In the spring of 1921, she actually spent several weeks in Sweden as a visiting professor at the University of Lund. And at that time, she's working with this person named Sig Bonds. You should try to remember that name. It's going to come up later. In Sig Bonds Laboratory, she actually meets my grandfather and his wife. And she chides my grandfather, who's a real go-getter at that time, because he comes to work on Sunday. And she says, no. And the child that's left at home, I think, is my father, right? She says, no, you should not be at work on Sunday. You should be at home with your family. And so according to my aunt, my grandfather took that to heart. And ever after on Sundays, he stayed home and took walks with the children. Now, in 1922, she presents her inaugural university lecture, which is titled The Significance of Radioactivity for Cosmic Processes. The press reports it as the significance of radioactivity for cosmetic processes. Now, in the 1930s is actually an extremely exciting time for nuclear physics. And I think this book does a better job than me, but I would like to convey, it's amazing how much they learned in that time and how little we knew about the nucleus of the atom and how everything was put together. In 1932, James Chadwick discovers the neutron. In 1932, Carl Anderson discovers the positron. In 1933, Wolfgang Pauli, who you'll hear a little bit more about, my uncle cannot talk about Wolfgang Pauli without laughing. But anyway, he proposes the existence of neutrinos to account for an apparent violation of energy conservation in certain nuclear reactions. So it's a very, very exciting time. And here you can see there's a conference in 1932. Here you can see Lise Meitner. She's sitting right next door to Paul Ehrenfest. And a lot of times when I show this, I make the comment that the percentage of women in physics is probably still very similar to what you're seeing here. Okay, but here's Lise Meitner, and there's two other women who I don't know who they are, but I'm going to point out this is Niels Bohr, this is Heisenberg, this is Hans Kramers, and he was my grandfather's best friend. He ended up in the Lorentz and Paul Ehrenfest position at the University of Leiden. I'm trying to think who else is here, probably other people. I do, however, know all of the women in this photograph. Notice there's only three, but this is actually Irene Julia Curie. She's the daughter of Madame Curie. She wins a Nobel Prize in her own right. This is her husband. This is Madame Curie. It's probably one of the last photographs of her alive. She dies shortly thereafter. And over here is Lise Meitner. And again, you can see a lot of the same cast of people, and I can't show you, but Hans Kramers, I know, is in here, and several other physicists that you would all recognize. So, politics. When Adolf Hitler comes to power in 1933, Meitner is actually acting director of the Institute for Chemistry. Otto Hahn is on sabbatical here in the United States. National Socialist Party members made their presence known at her institute. And she is protected because she has an Austrian passport. She is still an Austrian. But nevertheless, all other Jewish scientists, and that includes her nephew, Otto Frisch, and you're going to hear about her nephew later on, Fritz Haber, and I don't know if people know who he is, but he's the person, he was Jewish, who actually invented chemical warfare in World War I. And Leo Szilard and many other eminent figures were dismissed or forced to resign from their post. But somehow she manages to stay. Most of the others immigrate from Germany. But her response is to say nothing and to bury herself in her work. And she later acknowledges in 1946 that it was not only stupid, but it was also very wrong that she did not leave at once. And I think here I'm going to show you the first snippet of the movie, and I think you'll understand why I'm showing this and not talking about it, because they do a better job of showing you the environment.
The political situation is rather strange, but I very much hope it will take a calmer, more sensible turn. We were notified last week that, along with the black, white, and red flag, we must also display the swastika.
A Jew by birth, Meitner became a Protestant years before in 1908. But this conversion would not protect her as Hitler's dictatorship grows more powerful and close.
A rather large National Socialist cell has formed in the Institute, and it is all quite methodical.
Hahn returns to Berlin. He and Max Planck, president of the Kaiser Wilhelm Society, are appalled by National Socialist excesses, especially the persecution of Jews. But their greatest concern is to protect their scientific institutions. The Kaiser Wilhelm Society flies the swastika, uses Heil Hitler in its correspondence, praises the Reich in its reports, accepts Nazi policy in most matters, and compromises on the rest. Planck and Hahn welcomed the increased funding for military research at the Kaiser Wilhelm Society.
They did not share all the conventions of the Nazi politicians, but...
So that's the environment she was continuing to work in. But everything changed in March 1938, and that's because Austria was annexed into the German Third Reich. At that time, she immediately loses her passport. And in fact, she has to be issued a German passport. But it's not clear that they're going to issue her a passport. So what happens is that her friends outside start recognizing that she may be in trouble. And they start writing her, asking her to come to this conference, give us a talk. But I think people still back at the Institute were not clear that this would not blow over, and so they didn't know quite what to advise her, and I think initially they were saying, stay, this too will pass. However, by June 1938, Peter Debye actually writes to Niels Bohr and seeks help to find a position for Lise Meitner outside of Germany. Bohr sends requests out to so the Niels Bohr then starts writing everybody and seeing, can you find her a position? Now my grandfather, who as I said is actually head of the physics laboratory at the University of Groningen, he actually finds a position for her, but his money is kind of tapped out by that time. So all he can really support her at is for 1 year at a postdoc salary. And remember, she's now 59 years old and is a full professor and actually has her own department of physics. So all he can find for her is something at a postdoc level. A person named Adrian Fokker, and if you're in physics, you've probably heard about the Fokker-Planck equation. That's this one. He is actually working hard with the Dutch political politics to actually get her permission to enter Holland, because remember, she doesn't have a valid passport. They have to get permission that she can come into Holland and guarantee her funding. Oops, what happened here? Sorry. Okay. And then during all of this time, Monty Sigben, remember he's the guy that from Sweden, he offers her a position in Sweden. So on June 27th in 1938, Lise Meitner meets with her friends, Max von Laue and Peter de Baay and Rasmussen, and all of these people are actually genuinely nice scientists. They meet in Peter de Baay's Berlin home to discuss if she should go to Holland or Sweden, and Meitner decides on Sweden, and that's because the Holland position is only for 1 year. Sweden's actually offered her a position in a new institute, and she thinks, well, I can do more there. And so on June 28th, and somewhere in that time period, Coster and Fokker are told not to keep working for her, to come to Holland. However, during this time, things get a lot more serious. Somebody has actually written to find out, remember her status of immigration, can't she get a German passport? Somebody's written to higher ups in the Nazi Party, and I think her case actually came to the attention of Himmler himself, and basically they wrote back and basically said she's going to have to, and they didn't word it quite like this, but she was going to have to quit her job, but she wasn't going to be allowed to leave Germany. So at that point, she actually spends an evening on July 4th with Hahn and Hertz in de Baay's home, and they agree that she must leave immediately because it looks like they're going to start having this imminent, strict enforcement prohibiting departure of scientists from Germany. And of course, it turns out also that she's having trouble getting into Sweden because they're now saying, well, you don't have a valid passport, you can't get in here. So on July 6th, Peter de Baay, and I also want to give credit to Peter de Baay because I've heard recently he was actually accused of, or maybe not collaborating with the Nazis, but not standing up firm enough. But he obviously risked a lot here by helping her get out. Peter de Baay sends an SOS letter to my grandfather in Groningen saying, come get my assistant. She needs to, I've got an assistant for you to look out. But the SOS is his way of saying, come and get Lise Meitner out of Holland. So at that time, my grandfather and Adrian Fokker start again the process of trying to get permission, and they have to go all the way to the National Academy of Holland to get permission to say that we need to get her in. And finally, on July 11th, they've got permission to get her in. And my grandfather, who is in the north of Holland, he says he takes one of his neighbors who's a Dutch politician, and they take him to the Dutch side of the railroad passing, and they tell the Dutch border guards, don't worry, someone's going to come through here on Wednesday or tomorrow with an Austrian passport, but we're going to let him in. We have permission. Tell the German border guards that there won't be any problems. She won't get turned away at the border. And he was hoping that the border guards were friendly enough with the German border guards that this would happen without incident, but it wasn't clear. And he then leaves to go to Berlin from Holland, and he gets there late in the evening. He stays with Peter de Baay's family. And then Lise Meitner, they meet the next day at the train station. They haven't seen each other till then, so it's very casual. She's carrying a single suitcase, and they meet. Otto Hahn gives her a diamond ring, so she has something in case she needs to bribe the guards, and they actually get on the train. There is no trouble at the border, but right before, I think my grandfather takes the diamond ring, puts it in his pocket so that if the guards see it, they won't necessarily take it from her. And but they safely get there to Groningen, and Coster telegraphs Hahn that the baby has arrived safely. Now, my grandmother remarked after this, that they probably let Lise Meitner out because they thought she was the wife of somebody. They had no idea who she really was, but she did manage to get out. And this actually, I don't know, I can't actually read German, but you can see her signature. This was in my family guest book. And in those days, professors didn't stay at hotels. They stayed actually at people's houses. And so there's a guest book in my family that has amazing signatures. But this is hers, and it says, "Happily across the border brought," is the translation, Lise Meitner, 13th of July, 1938. Now, the thing that I learned from taking this photograph, which kind of confused me, is there's a signature of Sam Houtsmith. I don't know if people here know who he is, but he's one of the co-discoverers of the electron spin of the atom. And the reason I was so surprised to see his name is he is known for being at the University of Michigan. So by this time, I thought he was already in the US. He's Jewish. So I was going, what is he doing in Holland this summer, and why is he coming back and forth? Because it says intermittent. Why is he coming back and forth about the same time as Lise Meitner? Well, I'll explain that in a minute. This actually is information that came from my uncle. He remembers her at my grandparents' house. She said she was a very small woman, and she was kind of in a daze after this. And he remembers her walking around saying, "The Pope, the Pope." And his interpretation of this memory, and remember, it's only a memory, is that the only person she felt that could save her and save her position was the Pope. If he came out against this, maybe the German people would come to their senses. And she openly professes that she makes it to Holland with 10 marks and without her belongings. Now remember, she's 59 years old. She's just walked away, and she walked away without her pension. I think she was still expecting that she would be able to get her pension. It turns out she never did, but she had only a small suitcase and 10 marks. That's it. Now, she actually stays in Holland for 1 or 2 months, but then eventually she does go to Sweden, and she takes a position working at the new institute run by Mani Sigbahn. And that's actually very lucky, because Sweden is one of the few countries in Europe that was not overtaken by the Nazis. If she'd stayed in Holland, she would have been in trouble again. Now, remember I was saying I did a little bit of research about what was going on with Sam Houtsmith and why was he here. This is actually a picture of him. Sam Houtsmith, George Uhlenbeck, they are two of Paul Ehrenfest's students, and as I said, they're known for the electron spin. This here is Hans Kramers, and I have to say both my father and my brother were named after him. He was my grandfather's best friend, and again, you can see them. This is Sam Houtsmith at Paul Ehrenfest's house. This is their garden, and he typically had tons of garden parties for his graduate students after the physics seminar. This is, and I was going through the archives of Sam Houtsmith, from which are all of his letters and correspondence have been archived by the American Institute of Physics. So I was able to get this offline, and it's actually from my grandfather. It's in Dutch, so I can't translate all of it, but it says, "Dear Sam," and it's written on 11th of July, so the day that he actually leaves to go get Lise Meitner out, it's written, and he talks about the Dubai letter that the Dubai has written him a letter, an SOS letter, he says, basically to come to Berlin, and he's saying, I'm going to go there and I'll either come back with or without Lise Meitner, but I'm going in there to get her. And what he's really asking, although I understand that the middle of this letter is talking about equipment and physics, but at the bottom he's trying to set up an introduction between Sam Houtsmith and Lise Meitner to see if there was any possible position for her back in the United States. And I want to show you this picture only because it's the only one I have of Adrian Fokker, who again did play a very important role in getting her out of Germany. This was taken at the University of Leiden, the famous physics department, which is now the law school at the University of Leiden. And you see him, you see a number of other people. This is Sam Houtsmith, Hans Kramers, Paul Ehrenfest. But the one person you might be interested in is this guy here, that's Oppenheimer. He actually studied in Leiden for a few years before the war. And again, this is another photograph of my grandfather. This is Otto Hahn. You're going to hear a little bit more in just a minute, and Max von Laue. So the next movie talks about the discovery of fission. So I'm going to start that now. Here you go.
For Hahn and Strassmann, however, Meitner remains a member of the Berlin team. Throughout the fall of 1938, Otto frequently writes to Lise about their progress, often asking for advice and interpretation on their experiments with uranium.
One of the things they're looking at is a report by Irene Curie from Paris of a new substance that derives from the irradiation of uranium with neutrons.
The Curie substance is radioactive and present in amounts so small that it can only be detected by a Geiger counter. The new radioactivity behaves like barium, but Hahn and Strassmann do not think it is barium, since they expect only small changes in nuclear reactions. So they conclude that the new substance must be radium, which is chemically similar to barium, in the same group in the periodic table. November 9th, 1938, the night of broken glass, the Kristallnacht, an organized government pogrom against the Jews. 4 days later, Hahn travels to Copenhagen, where Lise is visiting the Bohr Institute. It has been 4 months to the day since they last saw each other, and he is eager to discuss his latest findings with her.
Meitner came to meet him at his train. They went to his hotel, had breakfast, and talked for hours. And we also know from Hahn's diary that Hahn met Niels Bohr, he met Otto Robert Frisch, and other physicists in the Copenhagen Institute, and they all objected to Hahn's new radium findings.
Hahn soon returns to Berlin, but in Europe the political situation is getting worse. Hahn realizes that he cannot tell anyone that he has met with Meitner, not even Strassmann. But he does tell him that Lise has urgently requested that they re-examine the radium findings. And so they begin a new experiment. To prove they really do have radium, they will separate it from all other elements. Their method is fractional crystallization, or fractionation.
They fully expect that they'll be able to separate the radium from the barium carrier.
But the experiments do not go as planned.
19 December 1938. Dear Lise, last week I fractionated thorium-X. It went exactly as it should. Then on Saturday, Strassmann and I fractionated our radium isotopes with mesothorium-1 as indicator. The mesothorium became enriched. Our radium did not. It could still be an extremely strange coincidence, but we are coming steadily closer to the frightful conclusion. Our radium isotopes do not act like radium, but like barium.
And what they find, and this is the big discovery, they find they can't separate those radioactive isotopes from the barium carrier.
There is something about the radium isotopes that is so remarkable that for now we are telling only you. They can be separated from all elements except barium.
And if you can't separate it, there's only one conclusion. And they reached this conclusion shortly before Christmas, 1938. Their conclusion is that those isotopes are not radium at all, but are actually barium.
Uranium has produced barium, radioactive barium. This is what Hahn and Strassmann have found. But how can a uranium nucleus change into barium, which is so much smaller? Hahn needs a nuclear physicist to explain this mystery. He turns to Lise Meitner.
Perhaps you can come up with some fantastic explanation. Before the Institute closes for Christmas, we do want to write something for publication, so please think about whether there is any possibility.
21 December 1938. Dear Otto, your radium results are very startling. A reaction with slow neutrons that supposedly leads to barium. At the moment, the assumption of such a thoroughgoing breakup of the uranium nucleus seems difficult to me. But in nuclear physics, we have experienced so many surprises that one cannot unconditionally say It is impossible.
Hahn was mystified as to how that could take place, how there could be barium among the reaction products.
Otto Hahn made a discovery in late 1938, but he didn't know the meaning of the discovery.
She is the physicist. It's up to her to explain the data from chemistry that doesn't make any sense.
Intuitively, Meitner was ready for the massive breakup of the uranium nucleus, even though the idea had no place yet in nuclear theory.
If there is anything you could propose that you could publish, then it would still, in a way, be work by the three of us.
It's Christmas. Lise is spending the holidays with friends. She invites her nephew, Otto Robert Frisch, a physicist, to join them. After their arrival, Frisch finds his aunt studying Hahn's letter and obviously worried about it.
Hahn and Strassmann had found that those substances were not radium, but barium. We took a walk up and down in the snow, I on skis and she on foot, and gradually the idea took shape.
This was no chipping or cracking of the nucleus, but rather a process to be explained by Bohr's idea that the nucleus is like a liquid drop. Such a drop might elongate and split in two.
At this point, we both sat down on a tree trunk and started to calculate on scraps of paper, and we found that the uranium nucleus might indeed be a very wobbly, unstable drop, ready to divide itself at the slightest provocation, such as the impact of a neutron. But there was another problem. When the smaller two drops separated, they would be driven apart and would require a very large energy, about 200 million electron volts in all.
Very rapidly, they calculate the debris left over by the fissioning, the breakup of uranium. And when they add it up, they find something missing.
She worked out that the two nuclei formed by the splitting of the uranium nucleus would be lighter than the original uranium nucleus.
There's missing mass. And then they calculate how much energy is locked in the nucleus of the atom. 200 million electron volts. That's hundreds of millions of times greater than the energy locked in a chemical reaction. And they said, what is the relationship between energy and mass? And then it dawned on them on Christmas Eve, 1938, E equals mc squared.
Whenever mass disappears, energy is created, according to Einstein's formula. Here was the source for that energy. It all fit.
Now, Einstein predicted it, but he didn't know how to unleash it. Here was Lise Meitner and Otto Frisch saying, this is how we do it.
In January 1939, Hahn and Strassmann published their barium finding in Naturwissenschaften. Meitner's name is not included. In February 1939, Meitner and Frisch published their theoretical explanation in Nature. They understand the process and name it nuclear fission. The discovery is a complete surprise and sensational news to scientists everywhere.
So, what happens then is that Otto Hahn in 1944 is awarded the Nobel Prize in Chemistry alone for the discovery of nuclear fission. In 1944, Germany is still at war, and he still cannot publicly admit his working relationship with Lise Meitner. But what happens is, even after the war, he does not recognize everything that she did for this discovery. Now, his Nobel Prize is in chemistry, not in physics. She's actually nominated to receive the Nobel Prize winner 12 times, many of those times by Niels Bohr. However, the head of the physics department is her boss, Monty Sig Bonds, and he actually has some issues with her. Now remember, when she goes to work for him at his institute, she's probably used to being a full professor. She's 59 at the time, and she was probably pretty depressed because she's had to live her whole life in Germany. So if there is some issues between them, some of it could be just explained because of that. But whatever, he actually is the head of the Nobel Prize winner, and he probably had a lot to do with why she never got it. Otto Hahn, however, never acknowledges her role, even after the war. Now, it's not like she goes without fame, and I'll explain that in a second. But she does write in a letter to Otto Hahn, I think this was actually in 1945 or 1946, "You all worked for Nazi Germany, and you tried to offer only passive resistance. Certainly to buy off your conscience, you helped here and there a persecuted person, but millions of innocent human beings were allowed to be murdered without any kind of protest being uttered. It is said that you first betrayed your friends, then your children, and that you would let them stake their lives on a criminal war, and finally that you betrayed Germany itself, because when the war was already quite hopeless, you did not once arm yourself against the senseless destruction of Germany." Now, I should say, even after this letter is written, they're still friends. They do remain lifelong friends, although I think some of these issues. Now, she has already won in 1924, she won the Leibniz Medal from the Berlin Academy of Sciences. Maybe because of this Nobel Prize issue, Eleanor Roosevelt recognizes everything that she has done. And in fact, after they dropped the bomb at Hiroshima, she's actually called in the press as the woman who escaped Nazi Germany with the secrets of nuclear fission in her pack, and she's given it to Niels Bohr, and he takes it to America. And of course, she was really upset because that's not exactly how it happened, obviously. But she does win this Woman of the Year by the U.S. National Press Club, and she actually does a tour of women's colleges within the U.S. In 1949, and she was very honored to receive this, she won the Max Planck Medal by the German Physics Society. And then right before she died, she won the Enrico Fermi Prize by the Atomic Energy Commission with both Hahn and Strassman. And as I said, in 1992, element 109 is named after her. So it's not like she was not recognized, but the Nobel Prize is never awarded to her. So I have a few additional comments here before I end the talk. One, these are just sort of interesting sidelines. This is actually a picture of Lorentz that was in my aunt's book, and I was like, oh my God, you know, here's Lorentz in our family photograph album. I was amazed. This was my grandfather's his physics apparatus. I'm not sure which one it was, but that's how they look like. And this was her physics equipment that was in Germany, and supposedly after, like in the 1960s, it was still there. However, there was no mention of her name associated with it. This is a photograph at the Leiden train station showing both Paul Ehrenfest and his son, Paul and Niels Bohr. I actually was at the Leiden train station not too long ago, and it looks a little bit different, but it's still there. And the reason I show that this is from the family photograph album, and again, I kind of like it. It shows the children of all the physicists. You see Paul Ehrenfest, then you see my father, then you see one of the Kramer's daughters, one of my aunts, another Kramer's daughter, somebody who we can't recognize, but I'm sure he was a physicist, and finally my aunt. So obviously they all played with their families on many occasions. This, and I'm doing a personal brag here, but this is from my aunt's, the one that now has Alzheimer's. When she was born, Paul Ehrenfest sent my grandparents a congratulations card, but also, you'll see, signed by Albert Einstein. So my aunt has a postcard that is congratulating her birth that is signed not only by Paul Ehrenfest, but also by Albert Einstein. This is a photograph of the house that Paul Ehrenfest lived in Leiden. It's unfortunately kind of overgrown now, but supposedly my cousin has seen it. There's a wall in there where I guess a lot of the famous physics debates were held, but he had scientists sign the wall. So if you go in there, it hasn't been painted over yet. It has Einstein's signature, it has Niels Bohr's signature, and somewhere in there is my grandfather's signature as well. And what I hear, as I said, somewhere in that house, the famous Einstein-Niels Bohr's debate at Paul Ehrenfest's house. And outside of that house that I just showed you, they have two plaques. One is for Professor Ehrenfest. He said, here lives and worked Professor Ehrenfest, but it also has a plaque for his wife. And she was actually a mathematician, a Russian mathematician, and it says, in her time, she made this house open for people and ideas. And I think that's a very beautiful saying. Again, this is a little bit of a brag, but this is Niels Bohr, and my grandfather, I put this down. My grandfather is sitting there. This is Niels Bohr. This is the Hungarian chemist von Hevesy that helped discover the element hafnium. This is Hans Kramers. And again, this is Wolfgang Pauli. And as I said, my uncle cannot talk about him without laughing. There's a few statements here. One attributed to him, he said, "That's not right, it's not even wrong." And also up here, and I'm going to read this, it says, to a certain degree, Pauli definitely had what we would now call psychic powers. His colleagues called it the Pauli effect, meaning that whenever Pauli entered a laboratory regularly, some experimental equipment would break down in an inexplicable manner. Despite their friendship, the experimental physicist Otto Stern even banned Pauli from entering his laboratory. So remember that. And there's just another photograph again of Pauli. And we don't really know where this is, but they're obviously on a roof, and I'm not really sure what's going on. This actually is a photograph of Judith Hertzberg. She is the Jewish girl that my family helped rescue. And although I know Holland is a very small country, I want you to know that she went on to become one of the most famous living poets in the Netherlands, and a selection of her work and form of a Rainbow Pocket was published in 1994. So she did live a successful life. I do happen to know that her family did all survive. And so did the other woman, Mevrouw Cohen, also lived and immigrated to Israel. And this last letter, and remember this is by Sam Houtzman, and I'm going to read it, so you don't have to read it. But I want you to know that I'm very fond of, I never met him, but he ended up working for the MIT Radiation Lab, which of course is, I work at MIT, and I'm kind of at a worked a little bit related to what would have been the MIT Radiation Lab. And then after the war, he was part of the team that went to try and discover how much the German scientists knew. But I should also say that his parents were killed in the Holocaust. My grandfather actually wrote to Heisenberg to try and intercede, and there was really nothing that Heisenberg could do. But anyway, the reason he was in Holland in 1938 is because he was offered a job, and he's obviously writing back to somebody at the University of Michigan to ask for more money. So I'm going to read you this letter because there's some very interesting comments. Okay, he says, to be asked to become the successor to our last Nobel laureate, Zeeman, is considered a great honor. Such a position brings with it a great deal of prestige and recognition. The laboratory is very beautiful and well equipped for optics. Nice work has also been done on isotopes, Thomson method, and there are possibilities for high tension nuclear work, probably neutrons only. It has its own shop with mechanics and glassblower, and is very nicely built. Next door is the laboratory of Professor Clay, who is well known for his cosmic ray measurements. The salary is about $4,600 a year. Considering the cost of living, this is equivalent with almost $6,500 at Ann Arbor. A professor here, listen to this, is said to be the second highest paid official. Of course, the way of living is different over here. It may be difficult to own a car and a refrigerator, but one can afford a large, beautiful home, servants, and nice vacation trips to France, Switzerland, Italy, etc. Now, listen to this. On the other side is the Jewish problem. It is disgusting to notice that good students cannot find employment in America. He's not talking about Holland. In America, only because they happen to be Jewish. Do you know that the official list of approved rooms for students at Michigan continues this year with the entry Gentiles only with many addresses? Do you know that Instructor R of History Department started his freshman class last September with the remark that there were too many Jews and that he would get rid of them by mid-semester. In Holland, there is no discrimination against Jews, in spite of a small German-paid Nazi group. There is, of course, some danger of invasion by the Germaniacs, he calls them, and the next war between Germania and England will probably be fought on Dutch soil and in Dutch air. Now, I just want you to realize that we're all guilty in some sense here, and it's not, you can't blame Germany for everything. But so I conclude this talk by saying I hope you've learned a lot about Lise Meitner here. Albert Einstein did call her the most significant woman scientist of the 20th century, and I really do believe that her name should not be forgotten. We should all be aware of all of her accomplishments and how hard, she had to do to get where she was. So with that, thank you.